Thank you very much, David, for your kind introduction. Please allow me to say that it's a great pleasure to be here and to bring the very best wishes of the United Nations to all. And I wish to thank the City of Edmonton for the invitation. And I'd like especially to acknowledge EPCOR, not only for what they do in providing superior water services for Edmonton and area, as well as widely elsewhere, but for the ongoing support of the United Nations University Institute for Water and Environment and my chair. I wish to acknowledge from the outset that this major conference, notwithstanding, not everybody in Alberta believes climate change disruption is an issue. There are many who simply deny climate change is happening. And on the other end of the social spectrum are those who are frightened by the prospect of climate disruption but feel helpless to do anything on a personal level about it. And they are concerned too about their inability to act on what they perceive to be a serious threat to our own and future generations. So if you are on either end of this spectrum or anywhere in the middle, I want you to know that I understand your position. I've been observing climate impacts on glaciers and alpine landscapes in the Rocky Mountains for nearly 50 years, and I have to admit that for the first 20 of those years, I can honestly say I wasn't entirely convinced that climate change was accelerating or that humanity could even affect the rate of warming. What climate scientists were saying about the possibility of warming made clear sense from the point of view of atmospheric physics, certainly. My problem was that even though I was studying glacial recession, I couldn't say that I'd personally witnessed clear evidence of accelerated warming. It looked to me like the cycle of recurrent glaciations brought about by eccentricities in the Earth's axis and orbit explained the decline of glacial ice in the Rockies and elsewhere. By the 1990s, however, the debate was really heating up, and still I couldn't understand if there was a climate change signal, why wasn't I seeing it? Well, then it happened. I saw it. It was the most amazing thing. It happened right on the street in which I live in Canmore, Alberta. It was January, and the temperature outside was 19 degrees Celsius and windy. But this didn't feel like an ordinary winter Chinook. It was nighttime. I went outside, and I couldn't believe what was going on out there. The snow in the hot wind wasn't just melting and the resulting water evaporating. The snow was sublimating. It was turning into water vapor without passing through an intermediate liquid stage. Then it hit me. The reason why I wasn't seeing the climate change signal was that it was happening when I was least likely to be outside to notice it. At night, in winter. And I checked the data, and that's exactly what is happening. Since then, research has demonstrated winter minimum temperatures where I live have increased 4 degrees Celsius in the last 50 years. The warming is even more dramatic in the Arctic. In the Yukon, winter minimum temperatures have risen 6.5 degrees Celsius since the 1960s. Another thing that I have observed is the greatest impact of this temperature increase is on water. Research has indicated in the Bow River Valley where I live, the presence of snow cover in the valley floor has diminished by 40% since the 1960s. More of the precipitation that used to fall as snow in winter now falls as rain. And we've also found that because of the winds, rates of sublimation of snow directly into water vapor in places like the Kananaskis is higher than almost any other place in the world. So as was pointed out, my work is to translate complex scientific research outcomes into language the average person can understand and that decision makers can use to craft timely and durable policy. Social scientists and big data analytics tell us that if you want to influence human behavior, that facts don't matter that much. Forget the science and concentrate on appealing to human instincts and loyalties. But in addressing the climate disruption problem, facts do matter, and so does science. It matters because it is from the science that we derive the utter urgency for action. The most important thing I have learned is that if you want to understand climate change, follow the water. And the reason behind this proposal is very simple. Liquid water, snow and ice respond directly, visibly, and measurably to temperature. If we follow what's happening to our water, it'll tell us what's happening to our climate and to our world. In the last decade, I must say, keeping up with breakthroughs in water and water-related climate science is like trying to drink from a fire hose. And after the last 4 summers, we've gotten to be very familiar with fire hoses, particularly in Western Canada. And I'm here to tell you that from a climate perspective, we better get used to putting out fires. Even before climate became an issue, we'd already begun altering hydrological cycle through rapid and expansive alteration of land use and cover. More than half of the entire surface of the Earth has been significantly altered by human activities. Land use and cover changes are only the beginning, however, of the human effects we're having on the global hydrologic cycle. Our entire earthly reality is defined by all the ways in which water reacts with nearly every element in the physical world. Change a few parameters that pertain to water, and the world that you see out your window is different. Some parameters, however, have more influence than others over the nature and function of any given hydro-climatic circumstance. The changing of a single defining parameter, temperature, for example, changes all of the other biogeochemical parameters. If our global temperature changes, and an entire new geometry is created around that change. And the most frightening discovery of this young century is that this is exactly what's happening. The rate and manner in which water moves through the global hydrologic cycle is accelerating, and it's happening right before our very eyes, here and everywhere. And the most profound changes to the hydrologic cycle relate to how much more water a warmer atmosphere can hold. And we've known for more than a century that for every degree Celsius of warming, we can expect the atmosphere to carry 7% more water vapor. So if you increase the temperature of the atmosphere by 2 degrees Celsius, the atmosphere can carry as much as 14% more water vapor. But if you raise the temperature of the atmosphere by 4 degrees Celsius, it'll carry 28% more water vapor, which changes everything. More water vapor in the atmosphere is making storms more powerful, heat waves more intense, and drought deeper and more persistent. And that is why recently identified phenomena such as atmospheric rivers demand our full attention. Atmospheric rivers have likely existed for an eternity, but only now, because of satellite remote sensing capacity, do we know of their full existence and dynamics. These corridors of intense winds and moist air can be 400 to 500 kilometers across and thousands of kilometers long, and they can carry the equivalent of 10 times the average daily discharge of the St. Lawrence. These huge rivers of water vapor aloft are carrying more water, and they have begun to cause flooding of magnitudes we have never witnessed before. It's interesting to observe that some 52 million cubic kilometers of water move through the global hydrologic cycle at any given moment. And it's estimated that 10 trillion tons of water are shifted from one hemisphere to the other in the form of winter snow cover during only one annual seasonal cycle. And what we're discovering is that because of warming, the ratio of snow to liquid water in the great seasonal redistribution of precipitation in the northern hemisphere is changing, with huge potential consequences for all of us. And nowhere in the world is this more evident than in the Canadian West. Research conducted by the Western Canadian Cryospheric Network has demonstrated that we lost some 300 glaciers in the Mountain National Parks region alone in the Rockies in the 85 years between 1920 and 2005. And I should point out to you that projections suggest that we can expect this loss to continue with 90% of the ice that exists in the interior ranges of Canada's western mountains expected to be gone by the end of this century. Now, what's interesting and important from a water point of view is that it should be noted the loss of glacial ice is a symptom of a much more problematic issue. the same warming that is causing our glaciers to disappear so quickly is reducing snowpack and the duration and extent of snow cover throughout the Mountain West. Snowpack and snow cover are now declining by 17% per decade. And if your lifestyle or business is in any way affected by snow and ice, you may wish to pay attention to this. It's also important to recognize that there is a direct climate connection between water and its diametric and symbolic opposite, fire. So if you don't have one, you often get the other. And higher mean annual temperatures, especially in northern Canada, are already resulting in increased wildfire risk. And a slower and wavier jet stream will cause the conditions that exacerbate the wildfire threat to intensify and persist longer in vulnerable places. So based on carbon dioxide increases alone, researchers here at the U of A predict a whopping 75 to 120% increase in the amount of area burned each year by the end of the century. And we know what this looks like. No Hollywood movie could even come close to depicting what happened in and around Fort McMurray in 2016. And then there was what happened in 2017 when the jet stream parked a huge high-pressure system over the west for months. At one point, it seemed that the entire province of British Columbia caught fire. In August, 19 wildfires joined to create the largest single fire in the province's history. We're also learning a lot about this from the lingering effects of drought from the fires in California. Expanded drought weakens trees, making them vulnerable to wildfire, and it's estimated that as many as 120 million trees died in California during its recent drought. These dead trees fueled horrific fires that threatened cities as big as Los Angeles, but the effects did not end there. What's really interesting is that when the rains finally arrived to end the drought, what happened is the rain fell over vast areas in which the fires had been so hot they baked the soil, making it impervious to water. And unable to penetrate the soil, heavy rainfall mobilized millions of tons of ash and burnt debris before flooding affected downstream areas with massive mudslides. And then I think there's the most important place at all, the place that we have to attend to most immediately, and that's the Arctic, where warming is already 3.5 degrees Celsius above the global average. Arctic snow cover has been declining at 22% a decade. Arctic sea ice has been declining at a rate of 12% per decade, but now something else is happening. What's really interesting is that we're starting to see bizarre winter temperature aberrations. And if you look at this view of the world in November of 2016, you can see that at that time, average temperatures above the North Pole and the Arctic Ocean were 30 degrees Celsius above normal. That was in 2016. And last week, polar temperatures were 35 degrees Celsius above normal. So where's the Arctic cold? Well, the Arctic cold is being shunted to mid-latitudes. But there's more. Multi-year ice is disappearing, and not as much sea ice is reforming. And there are two linked concerns here. The first is the impact of the loss of Arctic sea ice on weather patterns at mid-latitudes like ours, and the second being the potential for spontaneous release of methane presently entombed by Arctic cold into the atmosphere. So let me explain. Put very simply, the Northern Hemisphere jet stream, or what's often called the polar jet stream, are the westerly winds that are created as the world spins inside the torn blanket of its own atmosphere. And all of you have noticed, watching the nightly weather reports, I'm sure, that the jet stream's not a straight line. It curves around in these great meanders. And the first sign that something important was changing was that the increase we've been witnessing in recent years in the waviness of the jet stream began to bring Arctic cold air to ever lower latitudes than in the past. And people say to me all the time, well, how can there be climate change when our winters can be so cold? So here's what's happening. In addition to being larger in amplitude, the meanders move eastward more slowly, causing weather patterns to move more slowly. And it's these more persistent weather patterns that result in the intensification we are witnessing of events in which duration is an important factor, such as droughts, flooding, heat waves, and cold spells. And for evidence that this is happening, all you got to do is turn on the news. And you can do it any time of the year now. We see from the altered behavior of the jet stream that warmer atmospheric temperatures do not automatically translate into warmer weather. In a uniformly warmer and therefore more turbulent atmosphere, both warm and cold fronts end up and persist in places in the mid-latitudes in which they were not common in the past. And they oscillate, as we saw in the Brantford area just recently, between the extreme cold and the hot, and then you end up with rain and snow events and bizarre flooding events in midwinter. And the next troubling discovery we have made concerns the link between the behavior of the Northern Hemisphere jet stream and the amount of sea ice there is in the Arctic. Warming temperatures are leading to more sea ice loss, which in turn makes the jet stream even wavier, which brings even more warm air into the Arctic, which leads to more sea ice loss, creating a feedback that goes on and on. So the Arctic is now warming 5 to 8 times faster than the equatorial region. And as a consequence, there's also the related threat posed by natural methane and perhaps mercury releases from the warming land into the air and into inland and coastal waters. Now, I just want you to look at the picture on the left here. This is the researcher from the University of Alaska, Katie Walters. And you can see the bubbles on the right of the methane coming up into Alaskan lakes. We have exactly that. But she didn't realize just how much methane was being surfaced this way. She tapped the lake and put a lighter under it. And when I saw it, I thought it would be a flame of 6 inches. It was 15 feet. That's how much methane is being produced in this. And what we're seeing is that permafrost, though, is only one concern. As the Arctic Ocean warms, frozen marine sediments that contain methyl hydrates and clathrates are also thawing, producing methane gas that has begun to rise to the surface in these great bubble plumes that can be a kilometer across. And alarmingly, the overall combination of ice loss and the loss of snow in the Northern Hemisphere may contribute an additional 50% to the direct global heating effect caused by the addition of carbon dioxide to the atmosphere. So the question you've got to ask, and in a conference like this where we're trying to be as clear about where we move forward, is why aren't we fully doing something about this? Well, the first thing that's important to recognize is that scientists do not make rash pronouncements. They are especially loath to fall into the trap of pareidolia. And pareidolia is a human tendency to look at a random image and see a pattern where none exists. And the rapid retreat of Northern Hemisphere sea ice and the amplification of Arctic warming have all occurred only within the last 10 years. And 10 years is not enough time to distinguish the effect of changes in the Arctic system from other random events in the context of what's happening to the global cycle climatically generally. So what I'm saying here is that at the moment, in the Arctic at least, climate disruption is moving faster than science can keep up. And there's evidence that total Arctic sea ice loss could have an irreversible effect on the stability of the climate of the entire Northern Hemisphere. We could be approaching that tipping point within a few years, but we don't know. We wish we knew, but we don't know. And it's possible that we won't know where the tipping point actually was until long after we've crossed it. But again, we don't know. But we do know this. It's one thing to ignore what's happening, quite another to claim that climate change is a hoax. And there's another thing we know. Without stable water and climate regimes, sustainability will remain a moving target for us and for the rest of the world. And we also know that at the moment, if we believe the World Economic Forum in Davos, that our entire global economy is vulnerable at the moment to climatic instability. And it's for that reason that no matter where you live or what you do, dealing with climate disruption is something that you must think about, not sometime in the future, but now. And that is why this conference is so very, very important. Having a conference in Edmonton like this should give everyone hope. And I hope you'll believe me when I tell you I think we're getting somewhere. And one of the reasons for that is that our worldview is actually changing. What we're seeing globally is that a strongly entrenched narrative within our society that has pictured humanity as being somehow above global material and energy cycles, that it's so above that we no longer need to consider the finiteness of the Earth's resources. Well, that whole view has been proven to be wrong and dangerous. And what we're seeing is that gradually, with leaders like yourselves, the whole world's coming back down to Earth. And that process is well underway here, certainly if you listen to the presentations, but also widely elsewhere. In what is now being heralded as the second Copernican revolution, Earth scientists have discovered that our self-regulating planetary life support system is not just a collection of individual ecosystems as we once thought. The view that the planet needs to be understood as a unified, complex, evolving, biodiversity-based system has led in turn to three linked breakthroughs in the way we think about Earth system science. And the first is the concept of the Anthropocene, which suggests we have entered a new geological epoch defined by human influence on the Earth system's function. And the concept of the Anthropocene, I think, is posing some of the most challenging questions of our time. Should we accept the fact that we have irreversibly changed the world and now we have to run the show? Or should we do everything we can to return to conditions we've known in the past? The question's also asked, do we have a choice? Are we ready? What do we know about what we have to maintain? Do we even have any idea of how to replace elements of Earth system function that we have lost and are losing? And the second of these linked breakthroughs in Earth system science is the concept of the Great Acceleration, the extraordinary increase in human impacts on biodiversity-based Earth system function since the end of the Second World War, during which we've seen the most rapid transformation of the human relationship with the natural world in the entire history of humankind. And the third of the three linked breakthroughs in Earth system science is the concept of planetary boundaries, limits within which we need to stay if we are to create a safe operating space for humanity so that we continue to assure the stability of the planetary conditions that we live within now and that they might endure in the future. So when you look at it, climate disruption is only one of the Earth system boundaries that mark the safe zone within which we must stay if we want a prosperous future. And it's important to note that of the 9 critical Earth system boundaries, we may have already crossed 4. So what the loss of hydro-climatic stability tells us is that if we don't do the right thing right now, sustainability may be beyond our grasp. And sustainable development is really interesting because it has been defined in a lot of ways, especially in this country, but the most frequently quoted definition is from Our Common Future, also known as the Brundtland Report. And that report defines sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet theirs. Now, I wish to give some thought to that particular definition. Our situation is at the moment is that we have so altered the fundamental composition of the global atmosphere. We have generated effects and impacts that are cascading through all of nature. We have literally altered Earth system function to such an extent that if we're not careful now, the world future generations will inherit may not look like any world humanity has ever known. So what we see from this is the fulfilling the promise of meeting the needs of our generation without compromising the ability of future generations needs to be reviewed. And right now, I would submit to you from the science that I see, at this moment, there's no guarantee that we can offer that even we, let alone they, will be able to meet our own needs in altered conditions. So this means, and this is important, that we need to restore the world as we've known it before we can begin again to fulfill the terms of Brundtland's definition of what it means to be sustainable. We have to go back to go forward again. And when we talk about resilience, I think what we talk about about resilience is protecting what we have now. And what I would like to submit to you as a consideration is that we need to be presilient. Not only do we have to be resilient, but we need to adapt now for what is to come. What I'm saying is that to be sustainable in the future, we have to become both restorative and resilient. Well, so where's the hope in this? First of all, it's not all bad news. Sure, what we're seeing is frightening, but we've also learned more than we've ever known about the global hydrologic cycle. We've learned more about the functioning of the Earth system in the last 20 years than we have in all of the rest of human history. And what people at this conference have witnessed over the course of the last decade appears to be nothing less than a revolution in what we know. The growing accuracy of data, expanded understanding of Earth system function, greater knowledge and emerging common urgency are driving a revolution in the Earth sciences. Multispectral, space-based remote sensing is making the invisible visible. Combined with careful terrestrial ground truthing, what was once thought impossible may soon be possible. The holy grail of the hydrologic sciences appears to be within our grasp. And because of the work of Canadian researchers and initiatives like the Global Water Future Program, think about this: integrated flood and drought prediction and forecasting, and much more may very well soon be possible. And this conference underscores the importance of the science and the critical need to convey the outcomes of research to leaders. And what we're also discovering, and this is important from an aesthetic point of view, is the stunning beauty and implicate complexity of the Earth system upon which we depend for the predictability of the conditions on this planet, which makes the stability of our social, economic, and political foundations possible. The moment one can see in their mind's eye how additions and subtractions of heat or small amounts of greenhouse gases and aerosols can change the seasons or bring on or delay ice ages. The moment you see this, the system you look at when you look up to the sky is suddenly different. Suddenly, when you're looking upward into the bluest sky, it's not just inert air that you're seeing, but the suspended residue of every geological event and the cumulative exhalation of every ecological process that has ever taken place on or near the surface of the Earth and its oceans since the beginning of the world. And one might ask, well, how do you get your head around something this implicate? Well, the best way is to pick a single strand, water, and follow it into the larger climate weave. But it's also, I should point out, not just in science we're making progress. At the UN, we believe a new narrative, one that includes respect for the rest of life we share this planet with, and with whose presence we rely on for the stability of the Earth section to make it even possible. And as part of this new narrative, we need to create a new sense of time that extends forward to include future generations. And we need every nation on Earth to help create that narrative. The United Nations responded to the urgency and the opportunity of finally getting sustainable development right in September of 2015, just before the Paris climate talks. And their response was the announcement of a new framework for action in support of global sustainability that deals with the damage we are doing to other elements of the Earth system that are exacerbating and being exacerbated by climate change. And what the Transforming Our World Global Sustainable Development Agenda suggests is that we do really have to view sustainable development in a completely new light. And there is hope here, and this is where hope resides. Sustainable development as we defined it in the past is not enough. In order to gain even partial reign over accelerating hydro-climatic cycles, we have to enlist all the help nature provides us, which means restoring natural capacity. And I would submit to you that there is great power in realizing this, as the speakers at this conference have been saying, for it is at the local level where we live that we have the most power to affect change and to act most effectively in service of where and how we live and who we love now and in the future. And the question I'm often asked is this: well, what can I do? You know, I'm just one person. Well, first of all, I think it's important not to count on someone else to save you. The cavalry may not arrive in time, and as one person said to me earlier, we are the cavalry. Fortunately, there's a lot one person can do in the context of where and how they live, so there's no need to throw one's hands up in helpless despair. You can start certainly by aggressively reducing your personal carbon footprint, but there are also other actions that are not only helpful, but that can also be personally satisfying and life-enriching. You can make where you live, your yard, your property, your neighborhood, your community and its surroundings as natural and beautiful as you can make them. You can help restore the water and the air and do so in a way that quietly and without fanfare makes you an example that inspires others to do the same. What I tell people is start where you live, where you have the greatest power to affect change and to work outward from there. Be what you want to see. That's what one person can do. And if that's not enough, stop being one person. Join others with similar aspirations. And there's no downside to this. When we get over the immediate challenges, the long-term benefits of addressing climate disruption are clear. There is economic opportunity and quality of life reward in restoring damaged landscapes, in upgrading and refining infrastructure to address what the future will bring us, in developing and adopting new technologies, and sharing what we know profitably with others. And really, when you think of it over the long term, the opportunity before us is to create a cleaner, healthier, better world now and in the future. And the UN has just created a perfect vehicle for all of us to advance these aims. On December 21st, 2016, the UN General Assembly unanimously adopted a resolution entitled International Decade for Action on Water for Sustainable Development, 2018 to 2028. The decade aims to promote sustainable development and integrated water resources management, as well as increased cooperation and partnerships to support the implementation of the UN's 2030 Sustainable Development Goals with respect particularly to water and peace. And the huge opportunity will present itself starting on World Water Day, this coming March 22nd, with the announcement of the second International Decade of Action on the Global Water Crisis. The declaration presents, for us in Canada, a nested win-win-win opportunity. By actively participating in the ideals and values of this decade, Canada can improve its own water management while simultaneously helping others abroad to do the same. Canada provides its best policies, practices, and technologies to others, and in so doing, we advance and improve the water sector in our country, and we move together in the direction of a new Canadian national water ethic. And as we do so, we not only get our own house in order, we help create a better, more just, equitable, and sustainable world for all. Thank you very much.